Hello, this is Timothy with Growling Pigeon Studio. I want to tell you, before we get into the main video, I have a Twitter and I have a Twitch, and I'll be live streaming as I develop games later on. I don't really have a schedule set up yet, but I'll let you know. Either way, links will be down below in the description. But today, I want to talk about testing in our video games, and I want to talk at like a 3,000 foot view. So there's not going to be any code today, just a couple of stories. So if you don't like stories, this is not for you. All right. So first thing that I want to talk about is a scenario that I think is very common. It's not an exact scenario, so you can experience this, but with completely different specific details. The details that you can interchange are, rectangle, hitbox, that kind of stuff. But here's the scenario. You're working on a game, and you are creating your own rectangle structure, struct in C#. This rectangle has an X and a Y, it has a width and a height, and you want to be able to determine if rectangles overlap in any way, shape, or form, because you want to have some hitbox. And so you write some code, write up your struct, you write a static method that takes in two rectangles and see if they overlap with some logic. And then you test that logic by creating two rectangles that are white, and when they overlap they turn red, or whatever. I think that's fairly common, right? Okay, everything works. It seems to be just fine. So you work on your game. A month passes, and you've built all these layers on top of hitboxes. You have a player character, you have monsters, you have pickups, all kinds of stuff. Well, what you're finding, every once in a while you have a little bit of a bug, and you kind of fix it. But those bugs are more surface level. Your hitbox seems to work just fine until one day you create a level that has a really big monster, bigger than your player character. And when the player character uses his sprint ability and sprints into the monster, your player character goes straight past the threshold and into the monster. Okay, so now you need to detect if the player is within the bounds of the monster's hitbox. And this works great when the player is doing pickups. You have your player character and he sprints and hits a pickup item that is smaller than the player. Always works. But this time it doesn't. Well, where's the bug? Is it in the hitbox? Is it in the rectangle? Is it in the new monster that you just created? Well, guess where you're going to be looking? Probably in the new monster that you just created. So you'll probably spend a day, 2, maybe even 3, depending on how much you iterate and test as you develop. But eventually you'll have to figure out that your problem is all the way down in your rectangle implementation. You might get stuck on the hitbox implementation and say, well, I don't understand what's going wrong here. Rectangles are working everywhere else, but suddenly not here? This doesn't make sense, so it must be in the hitbox. And so you make all these assumptions. These assumptions lead you down the wrong paths, and it takes you a week to fully understand what's going wrong and how to fix it. Pretty bad. So this is where we would use unit tests. Unit tests are great because we can build them around the code that we write. Now, if we're just doing straight unit tests, no test-driven development, just unit tests, we build a couple of those around what we're writing as we write it, especially if we write it around breakpoints that we kind of expect, and if we write it around breakpoints that we notice. Now, I'm not talking about a breakpoint in Visual Studio, I'm talking about places where things can break. So we've got our rectangles, and we've got our logic, and we say, okay, this logic could break. I mean, it's really simple. I'll write a couple of unit tests just to make sure that it works. And hey, look, it's golden. Now I'm not sitting there writing the scene that has two white rectangles that overlap and turn red. I know that my unit tests are written in such a way that they should come back with a true result, and all the asserts work, except for this one method, and that's the one where one rectangle is inside of another, which works one way, but not the other way around. Well, now I can fix the bug right now. Well, maybe I don't write that unit test, right? Maybe that unit test is kind of forgotten, or I figure that if it works one way, it'll work the other way. Bad assumption, but it's an assumption that I've made, and I'm sure an assumption that many people have made. So what happens? So you got some unit tests that pass, and you're working on your game. Now that scenario that happens a month later occurs, and you have unit tests written around your monster, you have unit tests written around your hitboxes, you have unit tests written around your rectangle. Now, I would argue that you probably wouldn't even get to this point, because when you put your unit tests around your hitboxes, you might have said, okay, what happens if this is inside the other? Okay, what if this is inside the other one? Vice versa, and do a couple of other scenarios that you didn't see when you were doing your rectangle. But just for argument's sake, you get to that point where you have your big monster, say a dragon, and your player character that sprints into that dragon. Well, you've got your unit tests, and your unit tests say, oh no, this works, this works, this works, this works. Okay, well, I'm noticing that I haven't covered such and such scenario. So you write your unit test, and it fails on your monster. Well, that's odd. Okay, why does that fail? And so you go a little bit deeper. Oh, it's with the hitboxes. And so you notice that you forgot a unit test. You write one. Okay, that fails too. That's what I was expecting. So this is indeed the problem. So you're using unit tests to kind of figure out where the problem is, but as you're writing unit tests, it's creating an encyclopedia of what works and what doesn't. And presumably, hopefully, more of what does work. And so when you develop more features, or if you change logic, then that encyclopedia will help you stay in line. That's what we call backward or regressive testing, regression testing. Okay, so you've got to the point where your hitbox says, hey, I don't work under this scenario. Okay, so you are looking at your hitbox. The logic kind of seems it's around the rectangle. So you go into your rectangle class and you write a unit test that's missing. Like, oh, I'm so stupid. I tested if A is inside of B, but I never tested if B is inside of A. You write that unit test and it fails. You found your point. The unit tests helped you get to the bottom instead of sitting there thinking, okay, what's wrong with my dragon? Because you have no idea. You don't have anything that says this works for sure and this doesn't work. There's nothing there to put bounds upon what you're looking at as your problems or as your successes. So that's one of the main things that we use unit tests for, and I think is really important in video games, is it sets the bounds for your investigations when you have problems. Anyway, this has been my story time, I suppose, talking about unit tests in video games. Later on, I would like to talk about test-driven development, and I might turn this into a whole series about testing, maybe make 3-5 videos. We'll see. But I'll show testing in Unity at least. Maybe even test-driven development in Unity. Anyway, thank you very much for watching, and again, Twitter and my Twitch are both linked below. All right, you guys have fun. Bye.